Welcome back, everyone. We're going to be solving LeetCode 1448, count good nodes in a binary tree. So we're given a binary tree with a root and a node x in the tree is named good if in the path from the root to the x node there are no nodes with a value greater than the x node value. So we need to return the number of good nodes in the binary tree. So we can use depth first search to solve this, which is what I'm going to do, and we are obviously going to have some sort of count variable, right? So if we take a look at example 1, this path, right, the root value is always going to be a good node, and then the path from 3 to 4, 4 will be a good node because there are no nodes in the path from 3 to 4 which are greater than the 4 value. And that's how they determine if a node is good or not. So in the path from the root to the leaf node 5, there's 3 good nodes, and then in the path from 3 to the 3 leaf node, there's only 2. So, like I said, we're going to use depth first search to solve this. So we're going to have some sort of stack, and we obviously need to return some sort of count variable, right? Okay, so on this stack, what are we going to put on here? Well, we are going to put the root node. We are going to have a visited status of false initially, and then we are also going to have a maximum value, which we will change every time we update our path. So we'll say initially the maximum value is just going to be equal to the root value. Okay, now we have to run our depth first search. So while the length of our stack is not equal to 0, we're going to grab the node, we're going to grab the visited status, and we are going to grab the max value. Okay, now we have to check if that node is not none, and if that node has been visited yet. If it has been, we're going to do something. What are we going to do? We are going to check and see if that node.value is greater than or equal to the maximum value we have seen in the path so far. If it is, then we're going to increment our count by 1. Now, if we visit a node that has not been visited before, we are going to run a pre-order traversal. So that means we have to append our updated visited status first. So we'll append the node along with a true status and then the max val. Now we can go right and then left. So we'll check if node.right is not none. We will do something. And we will do if node.left is not none. We will also do something. So in here, what are we going to do? We are going to append the node.right to our stack. We are going to append a visited status of false. Now, what should be the max value here? Well, we can just simply say the max value that we're going to append onto our right path is going to be the maximum of our max value from our current node, or it'll be the maximum of the node.right.val, right? Node.right.val. So it'll either be the maximum value at our current node, or it will be our right value node. And then we can do the same thing for the left side. So stack.append the node.left, visit status false, and then the maximum of either our current maximum value or of the node.left.val. So this should run. So let's click run. And we do pass all 3 test cases, so we'll submit. Perfect, and it does pass the submission cases. So time and space complexity. Time complexity is going to be O of n, right? We have to loop through our tree and traverse each one at least one time. Space complexity is also going to be O of n in this case, right? Our stack can grow to the length of the number of nodes in our tree. So overall, time and space are going to be O of n for this problem. And that'll do it for LeetCode 1448.